Good morning. Assignment 4. Integration from 0 to infinity. Sine of pi x over x into 1 minus x squared dx is equal to pi. This is very important example and expected one. So we have to prove this integration is equal to pi. Now here I am having sine of pi x in the numerator. So this will be changed into e the power iota pi z. So I'm writing for sine of pi x as e the power iota pi z over, replace x with z simply in the denominator, z into 1 minus z square, where c is the contour indented at 3 points. Here if you put the denominator equal to 0, you get poles as z equal to 0, z equal to -1, z equal to +1. So the contour will be indented at 3 points, 0, -1 and +1, right? So if you look at this figure, I'm having here -1, here it is 0, here it is 1. So for that I'm having now 3 semicircles, smaller ones, gamma 1, gamma 2, gamma 3, having the radiuses for gamma 1 I'm having rho 1, for gamma 2 I'm having rho 2 as the radius, for gamma 3 I'm having rho 3 as the radius. So here if you look at here, I'm having the point 0, so this is rho 2 and this is negative rho 2. Okay, now here I'm having -1, so this point will be -1 minus negative rho 1, which becomes -1 plus rho 1. And this point will be, this is -1 plus negative rho 1, which becomes -1 negative rho 1, right? So here I'm having 1. So this point will become, this complete is from 0 to here. This complete is 1. So I have to deduct the radius rho 3. So this point will be 1 minus rho 3. And this point will be 1 plus rho 3. Similar is the case with -1 also, right? So make sure of all these points. Now we have to integrate this fz along this whole contour, because all of these poles lie outside the contour, right? And fz is analytic inside and on C. So by Cauchy's theorem we write the complete integration over C fz dz is equal to 0. Now this contour C is split into so many parts. So let's write first for minus R2 -1 minus rho 1. So first from -R2 -1 minus rho 1, and then we integrate along this gamma 1 semicircle, and then we integrate from -1 plus rho 1 to minus rho 2, and then the second semicircle gamma 2, and then we integrate rho 2 to 1 minus rho 3, then we integrate along gamma 3, and then from 1 plus rho 3 to r, and then we integrate along this semicircle tau from positive r to negative r, right? Please always remember, whenever you are integrating along the real axis, you have to write the function in terms of x, and whenever you are integrating along the curves, that is gamma 1, gamma 2, gamma 3, you have to write the function in terms of z. And also for tau also we have to write the function in terms of z. Only along the real axis we write the function in terms of x. So I have mentioned all the integrals. Now because it is on the real axis, I must write here f of x dx Along gamma 1, this is your curve. So write fz dz. Again, this is along the real axis. So this is f of x dx. For gamma 2, it is fz dz. Then again, this is along the real axis. So writing fx dx. For gamma 3 curve, this is f of z dz. And then again along the real axis, f of x dx. And then for semicircle tau, the function is in terms of z. So this complete integration is equal to 0. Now, calculating first for gamma 1, then gamma 2, then gamma 3. We will find the values, right? Okay. So first semicircle, I'm having gamma 1. Okay. Having the pole as -1. Right? Now, because it is the curve is going clockwise, so it is from pi to 0. So the first angle is pi, second angle is 0. So the formula is to calculate limit ρ1 tends to 0, integration gamma 1 fz dz. This will be equal to iota times theta 2 minus theta 1. So always it is 0 minus pi. Limit z tends to z0. Let me write iota 0 minus pi. Limit z tends to, here z0 is -1. Z minus -1, which will become z plus 1. F of z is e the power iota az, pi z. E the power iota pi z over z into 1 minus z squared. 1 minus z square means 1 minus z into 1 plus z. So z plus 1 will be cancelled out. So we have this is minus pi iota limit z is tending to -1 e the power iota pi z over z into 1 minus z, because this has been cancelled out. Z plus 1, okay. 1 minus z square is 1 minus z, 1 plus z. So this is equal to minus pi iota into, put z equal to -1 here, I get minus pi iota over 2. And in the numerator this is, okay. Now as e the power minus pi iota is equal to -1. So we get this. When you calculate, you get minus pi iota by 2. This will become -1. Put -1 here and -1 here, you get -2, and here this is minus pi iota. This is, okay, this is -1 and 1 minus -1, this is -2, and this numerator is -1. So minus minus cancel, you get 1 by 2 and then minus pi iota. So this is minus pi iota by 2, right? Okay. Then is rho 2 tending to 0 limit for gamma 2 semicircle, where z0 is 0. So again the formula iota theta 2 minus theta 1, which is 0 minus pi, limit z tending to 0, z minus 0 is z only, f of z. So this is minus pi iota, limit z tends to 0, z into, the function is e the power iota pi z over z into 1 minus z square. So z is cancelled with this z. Minus pi iota. Putting z equal to 0, we get 1 only. So this is minus pi iota. Then is for the third semicircle. Here z naught is 1. So this is iota 0 minus pi. Limit z is tending to 1. Z minus z naught. So z minus 1 into f of z. So this is equal to negative pi iota. Limit z tends to 1. Z minus 1 e the power iota pi z over z into. Okay, 1 minus z square is written as, I'm writing 1 minus z into 1 plus z. So z minus 1 will be cancelled out with this denominator but with negative sign. So let me take this negative outside common. I get z minus 1. So these two will be cancelled. This negative will cancel with this. I get pi iota. Limit z tends to 1 e the power iota pi over 1. So this is equal to minus pi iota by 2 because e the power pi iota is equal to negative 1. In the denominator also this is 1 plus 1 is 2. Right? So we have three values. For gamma 1 I am having the value this. For gamma 2 I am having the value this. For gamma 3 I am having the value this. Now putting all these three values in main equation, which is equation 1. Right? And also we have to find out the value for this tau. And this is always equal to 0. Now since you have to write this point 1 over z into 1 minus z square tending to 0 uniformly as z tends to infinity. And this is meromorphic function in the upper half plane as it has no singularity there. So by Jordan's lemma, this integral is 0. You can also mention e the power iota pi z over z into 1 minus z square is 0. Now, finally, letting all the small curves radiuses to 0 and the capital R tending to infinity. So letting rho 1 tends to 0, rho 2 0, rho 3 to 0 and R to infinity in the main equation 1. What we get? We get negative R will change to minus infinity to negative 1. F of x dx minus, now this is minus pi iota by 2. We have to put over here. Now here minus r will tending to, because r is tending to infinity, so minus r will be changed to minus infinity. And because rho 1 is tending to 0, so this is negative 1, the upper limit, right? And then put the value of this integral for gamma 1. We have calculated this as minus pi iota by 2. So I am putting the value here for gamma 1 curve plus, please check all the limits. This is from minus 1 to 0, f of x dx, and then putting the value for the curve gamma 2, we have calculated the integration. So this is minus pi iota plus 0 to 1 f of x dx, and the third value is for curve gamma 3 minus pi iota by 2, and then from 1 to infinity f of x dx, and by Jordan's lemma last integral is 0 along the semicircle tau, right? So this is minus pi iota by 2 and minus pi iota by 2. This will be pi iota with negative sign, and this is also negative pi iota, so this will come to the left hand side, becomes 2 pi iota, right? So minus infinity to minus 1 f of x dx plus minus 1 to 0 f of x dx plus 0 to 1 f of x dx plus 1 to infinity f of x dx is equal to 2 pi iota. Now this is from minus infinity to minus 1, then minus 1 to 0, then from 0 to 1, from 1 to infinity. So I am merging all these four integrals from minus infinity to plus infinity. F of x dx is equal to 2 pi iota. Putting the value of fx over here, I get minus infinity to infinity e the power iota pi x over x into 1 minus x square dx is equal to 2 pi iota. Now I have to equate imaginary parts now, because I need sign in the numerator now, right? And e the power iota pi x is cos of pi x plus iota times sine of pi x. I need sign in the numerator for the required result. So I will equate imaginary parts. So this will become minus infinity to infinity. Equating the imaginary parts, I get sine of pi x over x into 1 minus x square is equal to, here I am having 2 pi iota. So this will be 2 pi now. Again, this is your even function. So integration will change to 0 to infinity twice. Sine of pi x over x into 1 minus x square is equal to 2 pi. So 2 will be cancelled. Finally, I got the result. Integration from 0 to infinity sine of pi x over x into 1 minus x square, sorry, dx also there, dx is equal to pi. So this is the required result. Thank you for watching this video. Do like and subscribe for the latest videos. Thank you.